Okay, hope everyone's having a good day. Decent start to your week. So I don't have a warm-up for you today because we got a lot of stuff to go over. I wanted to jump right into it. We've talked so far this unit about finance charges. You know, the money that people charge you for the privilege of using their money. It's not yours, it's theirs, so they're charging you money to use their money. Usually that comes in the form of interest. And so far we've looked at simple interest, we've looked at compound interest. Last time we got into the idea of consumer finance, we talked about credit cards. And now we're going to be talking about the big loans that you might get. We're going to be talking about car loans. We're going to be talking about home loans. Pardon me. And the formulas we use today can even be applied to things like student loans. So the process is called amortization. We're going to talk about that. We're going to work on setting up a monthly payment formula. Let's spell formula correctly. And unlike when we developed the formula for compound interest, the formula for monthly payment is a little more complicated than we have time to get into developing today. So we're just going to talk about it and use it. We're going to have a lot of examples, and then we're going to look at the remaining balance formula. Some places we'll call it the future value formula. And all that is after you've been paying for a while, how much is left on the account? How much left do you have? How much do you have left to repay? And then we'll go through examples with that too. So when we're talking about amortization, so amortization is the process of paying off debt through regular periodic payments. Okay, so what that means, regular periodic payments. We're making payments in the same amount at the same interval of time. Usually, for most of the loans that we're going to be dealing with as consumers, those intervals of time is monthly. The interval of time we're dealing with is monthly. Some places you might have like quarterly payments, annual payments, something like that. Some businesses get deals like that. For most of us, we're dealing with monthly payments. Hey, when we're dealing with a consumer loan, we talked last time with our credit cards about the Truth in Lending Act and how that requires us to talk about the APR. All the interest rates need to be talked about in terms of annual percentage rate. And it's no different with big consumer loans here. So when we're making the process of, when we're going through the process of paying, we're paying off a loan in APR, given an APR, annual percentage rate, through regular periodic payments. The process is called amortization. You might hear like an amortized loan, things like that. Whenever you hear that, just think monthly payments. Okay, the formula to work this out, to find our monthly payment, is kind of gross looking, and it breaks a couple of the rules that we talked about in our mathematical modeling unit. For one thing, our variables are not always single letters. For our monthly payment formula, we have PMT, and they use PMT instead of P because we've used P for the principal investment or the principal loan for our simple and compound interest formulas. M, I guess you might use that for monthly payment, but M is often used in terms of slope of a line, so we're not going to worry about that. And T is time, so monthly payment, I guess we're just stuck with PMT. Okay, now our monthly payment is based off the amount that we borrow. And then we have a big ugly formula that goes along with it. So I take my interest rate of R, and I find the periodic rate. And remember, we use that with our compound interest formula. So if we're compounded monthly, our periodic rate was the APR in decimal form divided by 12. Since we're dealing with monthly payments, we're going to do the same thing. Our periodic rate is going to be R over 12. And then we divide by 1 minus 1 plus that periodic rate. Okay, so this might look familiar from our compound interest formula, and we are going to apply an exponent onto this. It's going to be negative n times t, where n is the number of compounding periods in a year, and t is the number of years we're working with. So this formula is ugly, so let's simplify it down a little bit. Okay, first let's define everything. PMT, monthly payment in dollars. A, loan amount in dollars. R is my APR in decimal form. N, so since we're dealing with monthly payments, N here is going to be 12. So T is years of loan. T, remember, standing for time or the term of the loan. So I said we were going to simplify this formula a bit. And I'm just going to get rid of the fractions and simplify our, get a simpler form for our exponent. And all I'm going to do is I'm going to replace the R over 12 with an I and the 12 times T with the capital N. Okay, where I is our periodic rate as a decimal, and capital N is total number of payments expected. Okay, so if I have a 10-year loan, I'm expecting 120 payments. So this formula here is a more generalized version. It lets us ignore the specifics of the monthly payment formula and lets us get things set up for any period of payments. But, like I said, most of what we're doing is monthly payments. So I is just the given rate over 12. Capital N is the number of years times 12. Whichever one is easiest for you to remember, go for it, or easier to understand. Because like with our other interest formulas, I'll give you this formula, but it's up to you to understand what it means and how to use it. So, I'm going to copy this over to our objective so we free up some board space, and then we will work on some examples. Okay, So we've got our formula there. We're going to refer to it a lot. But let's look at an example. If you look at your note sheet, we start with an example that a tech company is offering anyone who purchases a home entertainment system an annual interest rate of 9.5% for 4 years. If Andrea purchased the system at $59.95 from this company, calculate her monthly payment. So, in this example, we've broken down some of the things we need to do to calculate monthly payment. The first thing I ask you to do is calculate I, the periodic rate. And we said I was R over 12. And R is the APR of 9.5% in decimal form. And honestly, that's as far as we need to take that. Just like with our compound interest formula, we could find the decimal equivalent of this, but our calculators right now can handle these fractions. And if we switch over to decimals, we're going to lose some precision, and that might cause our final answer to vary a little bit. If you are not comfortable using the fractions and want to use the decimal equivalent, that's fine, but you also need to emphasize showing your work. So if you do any intermediate steps, rather than just put everything from the formula into your calculator at once, I need to see each of those steps. I need to see everything that goes into or comes out of your calculator. Otherwise, your answer might differ from mine by just a couple of pennies, but if I don't see how you got there, all I can do is say that it's wrong. Okay, the next thing I ask is find the total number of payments made over the life of the loan. So we said this was a 4-year loan. So 48 total payments. And again, you could leave this as 4 times 12, but for organizational purposes, it's probably easier to do the multiplication here and have the 48 so you have fewer parentheses to worry about. Okay. Next, I ask you to provide the formula you're going to use. Seems a little weird now because we only have the one formula for this unit, but keep in mind, we've got about a dozen formulas already for this unit. So I want to know what formula you're using. So, just recopy the formula in the box. That's all you need to do. And then calculate the monthly payment needed. So this is where you plug in all the values that you have to find the monthly payment. All right. So that's really all the tough stuff here. Now it's just let our calculator do the rest of it. But when you're putting things into your calculator, be very careful. We've got pluses and minus signs flying around here. We've got a negative exponent. We've got parentheses. So order of operations says that and our calculator is going to do this by order of operations. We're going to do what's in the parentheses first, then raise that to the exponent, then subtract from 1, and then divide this by what we get down here, and multiply the result by 49.95. Okay, when I did this, pause. Okay, when I put things into my calculator, I got about $150, $150.61. And remember, because we're working with a word problem, we want to include the units. So not just 150.61, $150.61. And even better, provide some context. What is this $150? It's a monthly payment. So our friend is going to be paying $150.61 a month. All right. Now from here, we can ask other questions that can help us check the reasonableness of our response. How much did this person pay in interest? Well, in order to find that, I am going to take the total repaid minus the total borrowed, because I'm paying back everything I borrowed and anything else pays off the interest. So here, I've got 150.61 times 48 payments minus 49.95. Okay, and our total repaid then is 7229.28 minus 49.95. So about $2,200 in interest was repaid. Now, I've been talking all semester about recognizing when your answers make sense in the context of the problem. And have an eye open for that. Okay? If your total repaid ends up being less than the amount you borrowed, something went wrong. And there's lots of opportunity for things to go wrong in this. Remember, when you're setting up this formula, parentheses are your friend. And I would err on the side of using too many parentheses just to make sure your grouping is correct. Also, consider what your answer here with the monthly payment is telling you. Okay, I've had students tell me that the monthly payment is 15 cents. Because, misplaced decimal or weird calculation, things went wrong and they kind of took a guess as to the format of the number. That 15 cents isn't even going to touch the amount borrowed. It's 15 cents a month. It's going to be 90 cents a year for 4 years. It's going to be 90 cents a month? No, it's not going to be 90 cents a month. It's going to be $1.80 a month for 4 years. So let's say $2 a year for 4 years, $8. They're going to be paying $8 back. That's since our amount borrowed is accumulating interest, we're going to end up owing more money at the end than when we started. And I've also had people say, like $150,000 is the monthly payment. If that happens, then we're repaying our initial loan amount 30 times over with just the first payment. What are we going to do with the other 47 payments? So you may not know yet what a correct answer looks like or what a reasonable answer looks like, but you should have an idea of what an unreasonable answer looks like. So be aware of that. Okay. Now from here we do another example and then move on to remaining balance formula, but we're out of the time for the 20-minute demo, so thank you.